Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Anis Yazwinda binti Zulkifli. My matric number is 10DTK21F1026. Okay, so today I'm gonna make a semiconductor device EOC presentation. Question 1. By using a suitable diagram, explain how an N-type semiconductor can be produced. The answer is an N-type semiconductor results from implanting dopant atoms that have more electrons in their outer bonding shell than silicon. The resulting semiconductor crystal contains excess or free electrons that are available for conducting current. Okay, for question 2, discuss the difference between a full wave center tap rectifier and a full wave bridge rectifier. The answer is the main difference between bridge rectifier and center tap full wave rectifier is that bridge rectifier produces almost double the output voltage using the same secondary voltage. Then center tap rectifier, as the name suggests, requires a center tap transformer secondary winding. Okay, for question 3, with the aid of diagrams and output waveform, discuss the difference between amplifier class A, B, and AB. Okay, then the amplifier classes are always defined as follows. First, class A. The amplifier single output transistor conducts for the full 360 degree of the cycle of the input waveform. And for class B, the amplifier 2 output transistors only conduct for one half, that is 180 degree of the input waveform. And for the last, class AB, the amplifier's 2 output conduct somewhere between 180 degrees and 360 degrees of the input waveform. Okay, first, class A amplifier operation. For class A amplifier operation, the switching transistor's Q point is located near to the center of the output characteristic load line of the transistor and within the linear region. This allows the transistors to conduct for the complete 360 degrees, so the output signal varies over the full cycle of the input signal. The main advantage of class A is that the output signal will always be an exact reproduction of the input signal, reducing distortion. However, it suffers from poor efficiency because to bias the transistor in the center of the load line, there must always be a suitable DC quiescent current flowing through the switching transistor even if there is no input signal to amplify. Okay, next is class B amplifier operation. Two complementary switching transistors are used with the Q point, that is its biasing point of each transistor located at its cut-off point. This allows for one transistor to amplify the signal over one half of the input waveform, while the other transistor amplifies the other half. These two amplified halves are then combined together at the load to produce one full waveform cycle. This NPN-PNP complementary pair is also known as a push-pull configuration. Because of the cut-off biasing, the quiescent current is zero when there is no input signal. Therefore, no power is dissipated or waste when the transistors are in the quiescent condition, increasing the overall efficiency of a class B amplifier with respect to class A. Okay, for class AB amplifier voltage biasing, here the biasing of the transistor is achieved by using a suitable fixed bias voltage applied the basis of TR1 and TR2. Then there is a region where both transistors are conducting and the small quiescent collector current flowing through TR1 combines with the small quiescent collector current flowing through TR2 and into the load. When the input signal goes positive, the voltage at the base of TR1 increases, producing a positive output of a similar amount, which increases the collector current flowing through TR1, sourcing current to the load RL. However, because the voltage between the two bases is fixed and constant, any increase in conduction of TR1 will cause an equal and opposite decrease in the conduction of TR2 during the positive half cycle. Okay, for question 4, sketch and label the schematic symbols for an E-MOSFET and explain its operation. The E-MOSFET or enhancement MOSFET can operate in only the enhancement mode with a positive voltage above a threshold value on the gate and induced channel of thin layer of positive charge is created. The conductivity of channel is enhanced by increased VGS and thus pulling more electrons into channel area. Okay, for question 5, explain the characteristic of the UJT. The main characteristic of UJT is when it is triggered, the emitter current increases regeneratively until it is limited by emitter power supply. Due to these characteristics feature, it is used in applications like switching pulse generator, sawtooth wave generator. That's all from me. Thank you.